Hello everyone, welcome back to the class real-time system. Today we are going to discuss about the task management. So far we have discussed about the introduction and also the multitasking, operating system, priority structures and the scheduling strategy. So far we have discussed about. So today we are going to discuss about the task management in this video. Okay, so the task management is nothing but the many of the task. The task management main function. It's nothing but the basic functions of the task management is nothing but it's keeping the record. It's keep a track of the record of all the states. I mean each and every task it will keep track of the record and to schedule an allocations of the CPU time to each and every task and perform that context switching. That is to solve the status of the task that is currently is being the CPU and restore the status of the task that is being allocated to the CPU tab. So we know that to keep track of all the records. Okay, and the second one is the scheduling. Scheduling is nothing but allocating the CPU to the each and every task, and third one is to perform the context switch. Okay, so the context switching is nothing but saving the current status of the process. Whenever it is executing again, we need to restore the operations again. I mean the current status again. So that's why we are going for the context switching. So these are the basic three functions of task management. So based on this, the task management function which is splitted into two. One is the scheduler and second one is dispatcher. So which determines which task is to run the next and keep track of all the state of the task. That is nothing but scheduler. Dispatcher is nothing but which performs the context switching. Okay, so these are the two functions of scheduler task management. So typically you can see this, there are 5 states. The 5 states are existent state and non-existent state and suspended state, ready state and active state. Active state is nothing but a running state. Okay, so whenever start from the ready state. Okay, ready state is nothing but the number of process which will be there in the queue ready to use the CPU. Okay, so among the task only one task will be selected for the scheduling. So that task is take transition from the ready to the active state. So in that it will be representing run, and from the active state there is a possibility of suspended state, there is a possibility of existent state. Okay, so when it is transmitting from active to the suspended, so whenever it is completed, that particular task will be suspended. Okay, whenever the executions are completed or otherwise it wants to wait for some other activity need to perform, then it will be turn off condition put into the existence queue. This existence is nothing but the operating system knows that particular thing, but the priority will not be assigned into that for that particular task. So that is nothing but an existence task. And okay, now after this, from the suspended state, there is a possibility of active state and also there is a possibility of existence state. There is a possibility of extension state. So from the suspended state to the ready state, whenever it is active, then that will be a transmission from suspended to the ready state. And whenever it is in need not required, that particular task must be put into the delayed task. So then the priority will be removed and that will be put into the existence state. And the possibility of existence to the ready state whenever it is possible, so it initiate the turn on state. Okay, so from the ready state to the there is a possibility of existence also, and there is a possibility of non-existence and there is a possibility of non-existence to the existence state. So whenever need to destroy the existence task, so that state transition from existence to the non-existent, and non-existent to the existent it will whenever it is created. So this is nothing but a state transition diagram. Okay, so these are the tasks. What are the tasks are there? Active task, ready task, suspended task and existent and non-existent task. So active task is nothing but a running task. So this is the task which has control of the CPU. It will be normally be the task with the highest priority of the task which are ready to run, and the ready task is nothing but an runnable task. Okay, so it is ready in the queue for the CPU execution. So there may be a several tasks in the state, the attributes of the task and then resource required to run the task, it must be available for the task to be placed in the ready state. And the next is suspended state. It is nothing but a waiting, locked out and delayed. So the executions of the task which is placed in the state has been suspended because the task which requires the some resources which is not available, or because of the task is waiting for the some signal for the plant. So that's why it is put into the suspended state. Okay, existence is nothing but it is nothing but an off state. That means operating system is aware of the existing of that particular task, but the task has not been allocated the priority and has not been made the runnable. Okay, so non-existence is nothing but a terminated state. The operating system has not as yet been made aware of the existence of the task, although it may be a resident in the memory of the computer system. So the status of the task is may be changed by actions within the operating system. So the transitions from the ready to the active can only be made at the request of the dispatcher. So these are some of the state transition commands which is used by the real-time operating system. See, actually the operating system doesn't know where to transmit from this state to that state. So it operates based on the command which is generated inside. Okay, so these are the commands which is used real-time operating system. So of C01 which represents turn of the task leaving the memory marked as occupied, and OFFC02 it is nothing but a turn of the task leaving the memory marked as unoccupied, and then DELC01 it is nothing but a delayed task leaving the memory marked as occupied, and the delay is calculated using the current value of the time. And then del C02 it is nothing but a delay the task leaving the memory marked as unoccupied. Delay is calculated as per the del 01. Okay, so the delay C03 it is nothing but a delay the task leaving the memory marked as occupied, and then delay is calculated by adding the delay to the value of the time stored in the task descriptor. And the TPN C01 it is nothing but on the turn the task is on will be accepted if the task is on or off or delayed either on the on constant that can be placed in the task descriptor or specified turn on time. Okay, TPNC02 it is a turn on the task will only be accepted if the task is in the off state, and then TPNC03 run the task immediately regardless of the priority will be accepted if the task is on or off or delayed. So these are some of the commands of real-time operating system. So the next is task descriptor. So in this task descriptor is nothing but the information about the status of the task is held in the block of memory by the real-time operating system. So the block is referred to as the task descriptor, process descriptor, the task control block, and then task data block. Okay, so the task descriptor which is represented by TD, process descriptor is represented by PD, the task control block is represented by TCB, and then task data block is represented by TDB. Okay, so these are the blocks. Actually the task descriptor which is also called as PD or TCB or TDB. Okay, so what are the informations which is there in the task descriptor? So the informations are the task identifier, identification of the particular task which is represented by ID, the task priority which is P, and current state of the task, and area to store the volatile environment or a printer to the area of the storing of volatile environment, and the pointer to the next task in the list. So these are the things which is there in the task descriptor. And you can see this the linked list of the structure. So what is the list which is maintained by the execution? So here you can see that the active task, one of the task which is active, the head and tail which is represented, the head which is pointing to the next task where it is exactly executing. In the first one it is in active state. In the active state there is no only one task will be the under the CPU execution. So the heading and tail which represents the only one field, only one task, only one ID. So that ID which is represented by 10, and the task descriptor and pointer will be there, the pointer which is not representing any other task because only one task will be under the CPU at any time. Okay, and second is ready. In the ready queue there are number of tasks will be available in the queue. So the pointing, heading and tailing the pointer which represents the many thing. Okay, so the header first represents the first ID 20. Okay, and after executing that, that 20 ID is pointing to the next one 9, and the 9 which is representing pointing to the next one 6. So you can see that the tail which is representing the end of the task. End of the task is nothing but 6 in the queue. Okay, and suspended state. So similarly in suspended state also the many of the tasks will be in the suspended state. So the head and tail which represents here. So the head is pointing to the first suspended ID, that is 25, and then 25 is pointing to the next ID, it's 32, and the tail is also represented as 32. It's always the tail which is represented by end of the task. Okay, and the existence state is also which contains the many of the tasks. So the head which represents the ID is 16 and then TD. Okay, so the next the TD 16, that is ID 16, the task 16 which is pointing to the next process, that is 8 is pointing to the 3. So the 3 is the last task in the queue, I mean existence state. So the tail which is representing the 3 in the queue. Okay, so like this how the link structure will be exist in the real time operating system. And real time clock interrupt handler, scheduler and real time clock interrupt handler. So you can see that the real time interrupt handler and also a scheduler of the clock level task must be carefully designed as they are run at a frequent interval. So here you can see that there are many of the tasks will be there. Okay, system command which changes the task status, typically it is shown in the figure. So here you can see that running task, delayed task, on task, off task, and non-existence task, and locked out. Okay, so you can see the some of the commands which is there, tpnc1, tpnc02 and tpnc01, tpnc03, del 0x, and also here tpnc01, tpnc03, OFFC01, OFFC02, and then tpnc03, and also a create and resources are available and request the resource. So like this how the many of the operations are there. So whatever we have talked about in the previous the state transition diagram, it's same thing but here it is represented as a command by using a RTYS command. Only the thing is here, only the extra thing which is represented here is locked out process. So when that particular process will be locked out, when there is no resources are available, that time it will be in the locked out process. Okay, so the whenever it is running state, the state transition from the running to the locked state, it is requesting a resource. So if the resources are available, then it will be in the on state. Okay, then it will be executing under the CPU, and whenever need to put a particular task in the delay, so it will be in the delay state, or otherwise it will be in the on state, or otherwise from the running to the off state to the non-existent state. Now non-existence to off state can be created by creating a particular task. So this is what the scheduler and real-time clock interrupt handler. The same thing whatever we discussed earlier, only the commands which is implemented here. Because why it is? Because the operating system doesn't know the state transition one to another. By sending the internally the operating system which send the commands. So here we talked about there are the two tasks which is there, task descriptor and also a scheduler, right? Dispatcher and scheduler. Scheduler will be selected any one of the process under the CPU execution, and the dispatcher, that selected process will be executed under the CPU. So whenever it is selected, that particular command will be sent. Okay, so that operating system, that particular task will come to know that particular task will be selected for the CPU execution. So once if it is selected, then it will be under the execution. So once if it is completed, and again the internal command will be generated. So it come to know that the operating system and all other states will come to know that that particular task is completed the running time, and it will be in the delayed state or running state, whatever it may be. So that is what it is given in this diagram. Okay, and how the interrupts will be assigned to this. The system here, there is a differentiation between the tasks which are suspended, awaiting, and then passage of the time, and it is marked as a delayed task, and those which are waiting for an event are the system resources. These are marked as a locked out process. So the system does not explicitly supports the base level task. However, the lower 4 level priority levels of the clock that can be used to create the base level systems. A free time execution is provided which is used to run at the priority level n is equal to 3. So here you can see that the dispatcher, so there are number of priority slots are there, 1 to n number of priorities are there. In that the real time task and also a free time task. So the real time task and then free time task, the priority will be assigned. The high priority will be assigned to the real time task, and then free time slots, the priority will be assigned to the low level task. So among these, the dispatcher will be selected any one of the process, and that will be sent under the CPU execution. Okay, and dispatcher. So what is a dispatcher? So the dispatcher scheduler has two entry conditions. What are the entry conditions? So the real time clock interrupt and the any interrupt which signals the completions of an input output request. So the task suspension due to the task delayed or completing or requesting on input output transfer. So here you can see this, the entry point, it is nothing but a real time clock interrupt service routine. It is nothing but an interrupt. Okay, it will say the status of the active task and checks whether the priority level is -1 or not. So it will be increment the priority level. Okay, it will be increment the priority level. So the task B is nothing but an entry B is nothing but an the task system which commands request. Okay, input output transfer control request. Okay, transfer the request, priority level, current priority, say the status of the active task and the priority level, the current priority. Okay, so whether need to be increment or not. So it will check the priority level and it will increase the priority level, and then priority level is greater than the maximum one, it checks. If it is yes, again it is going for the back one and the check the priority levels if no. If it is not, and then task will be on, it will on the task, and if it is no, again it is go for the previous one, increment the priority task. If it is yes, then the task to the memory, task in memory, check whether it is transfer the task to the memory. Okay, and the restore the status of the task and exit the task. So this is what which is performed in the dispatcher. This is how the dispatcher will take and dispatch the event and put under the CPU execution. Yes. So these are the references. In this video we have discussed about the task management, how the task management, what are the functions of the task management, what are the functions will be divided into the task management, how many number of tasks are there, when the transition from one to another, how it will be performed, and what are the real time clocks are there, the commands, the internal commands, how it will be generated, if it is generated, how the state transition diagram will be, and how the scheduler which works and the priority which works and dispatcher which works. Okay, so this is what we have discussed in this video. So according to the VTU, this is one of the important topic. Okay, I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.